5.4, we're going to learn two new methods to solve quadratics. We're going to start taking all these quadratics and solving them. We have learned basically one method of solving so far, which is probably the most common, that's factoring. So if an equation factors nice and neat and it's a happy little math book problem, then you can factor it. If it's not, then you have to have other methods. So the two methods we'll talk about today are square rooting and completing the square. So square root property, you can basically take the square root of both sides of the equation and the equation will still remain true. And this will be beneficial to utilize when we are missing an x term in our equation, because then we could get x squared by itself. So here's the property from the book. There's some reading math. Anyway, let's get into it. So these equations, what you should notice about them that are different from the ones that we solved last week are that they are essentially missing an x term. They're missing the bx term. So if they're missing the bx term, we don't have to factor. We can square root both sides after getting x squared by itself. So square root method. Reason why this works is because we're able to get x squared by itself. So if I'm over here getting x squared by itself in this equation, I have 4x squared equals 48. Divide both sides by 4, I get x squared equal to 12. And now I have x squared all by itself, so I can square root. And this happens when you are what? Missing an x term. Yeah, missing the bx term. Okay, so now we have x equals, when you're solving an equation and you take the square root, you have to consider the positive and negative case of that root. So plus or minus the square root of 12, which is also 2 root 3. So plus or minus 2 root 3. How did I get 2 root 3 out of root 12? Well, if we go back to the beginning of the year, we simplified radicals, and root 12 is the same as root 4 times root 3, which is root 4 is a perfect square, 2 root 3. Okay, remember, if you have anything, just jump right in. If I don't see it, you can give my attention. Same thing over here. This one's a little different because it works out kind of nice, neat, and happy. 4x squared equals 25. X squared equals 25 fourths. Huh, that's weird. That number is a perfect square. So when you square root both sides here, and I square root 25 fourths, I'm going to end up with plus or minus, what's the square root of 25? Is 5 over square root of 4 is 2. So that one actually would have factored because there's no root in there. You could have factored that by doing difference of squares, right? It would have been like 4x squared minus 25 equals 0. And that is 2x plus 5, 2x minus 5. And that would get you same answer. Jada? Yeah, when you are like, so we'll learn more about this down the road, but if you're solving a quadratic equation that's the second power, there's going to be 2 answers every time. So the degree, in this case, is 2. It should match how many solutions you have. Okay. This one is kind of an interesting problem, and I didn't really notice right away that what happens in this problem, so I'm just going to take you through how I would do this one normally. So if we have a quadratic equation, it's pretty common to set it equal to 0. So that means minus the 28 from both sides, right? And then we set it equal to 0, and in this case, we're not missing any x term. So we're left with x squared plus 12x plus 8. equals 0. And then I'm thinking, okay, does that factor? And it doesn't factor, so now we're kind of stuck at this point. We don't really we don't have any method that we've learned to deal with this. However, two things we're learning to do today are complete the square and square root both sides. Can I use the square root method on this one? I can't because there is an x term. So I'm going to have to do complete the square method. So I'll show you complete the square method, and then you'll kind of see what happens in this one. But if I complete the square on this, that's where I add the special constant to make it a perfect square trinomial. So that's x squared plus 12x plus the special number equals negative 8 plus the special number. I add that to both sides. The special number in this case is half of 12, right? So it's always half of the x term, half of the coefficient of the x term squared, so that's 6 squared is 36. So when I add 36 to both sides, something kind of funny happens. On this side I have 28, and on this side I have what I started with. So it actually was a perfect square, and I just didn't recognize that right away when I did that today. So this ends up being x plus 6 squared equal to 28. Okay, so if you can write one of the sides as a square like that, now you can use the square root method. Dave?
The special number
Yeah.
also was the c value at the top. Will that always be the case? Will there just end up being the same?
No, this is just a like a coincidence. Yeah. So he asked if the c is always going to be the same as the special number to add, but in this case, what I didn't recognize right away was that this left side was just a perfect square to start with. See, it was just x plus 6 squared. So, but we got there anyways, the same result, just a longer path. So then this ends up being down here, x plus 6 equal to plus or minus the square root of 28. That's going to be 7 and 4. So that's plus or minus 2 root 7. And then to get x by itself, I need to move the 6 over by subtracting 6 from both sides. So my very final answer here, all nice and simplified, is negative 6 plus or minus 2 root 7. So it's not a very nice, neat, friendly problem. And that's because it doesn't factor. Yeah. You always want to put the rational part first. So you do want to do plus or minus the root part. Because, and to add on to that, really this is negative 6 plus 2 square root 7, or negative 6 minus 2 root 7. So 2 times the square root of 7 is square root of 7 is somewhere between 2 and 3. So it's like 4 point something, right? Maybe it's even 5, I don't know. So this is like negative 6 plus 4 something-ish. So, it's a number. It's just you would have to find a decimal approximation for that number. It's not a nice, neat number, integer. Okay, moving forward. So now we talk more about, how do we solve by completing the square? So you want to move your constant stuff over, or maybe it already is over like this one. Add your special number, which is half of negative 4 squared. So in this case, it's 4 to both sides. You end up with x minus 2 squared equals 31. And at that point, now you can take the square root of both sides of the equation, and don't forget the positive and negative root. So then you have x minus 2 equals plus or minus square root of 31. That's a prime number, so that's not going to simplify at all. So this one ends up being just positive 2 plus or minus square root of 31. No, that's just the square. Squared cancels out the square root there. Yeah. Okay. So when you're solving, if we just kind of go back and highlight what we've done so far over the unit, the first and probably best way to solve is by factoring if it factors easy. And so you don't want to get kind of tunnel visioned into just one process. So if it factors, you should factor it. Does this one factor? Yeah, this one's actually a really good one. What does it factor as? Yeah, a lot of people think 6 and 4, but that's actually not it because the last term is negative, so the signs have to be opposite. And 6 and 4 add up to 10, but these aren't going to add, they're going to subtract, so it's 12 and 2. Another one of those tricky ones. So the best way to solve if it factors easily is by factoring. And so in this case, my two solutions are going to be x equals negative 12 or 2. But maybe you didn't recognize that and you just went and completed the square. That's fine. If you went and completed the square, it would just look like this. So you'd have x squared plus 10x plus something equals 24 plus something. That something is going to be 25 because it's half of 10 squared, so 5 squared is 25. And now you end up over here with x plus 5 squared. And on the right side you have 49, which is a perfect square. So when you square root both sides in this case, you're going to get plus or minus the square root of 49, which is essentially plus or minus 7. So now when we have our final answer, it's negative 5 plus or minus 7. That's going to be negative 5 plus 7 is 2, and negative 5 minus 7 is negative 12. So you end up with the same thing. It just was a little bit more of a longer path to get there. Which that's, kind of the neat part about algebra and math. Look at all these different ways you could go, and that's exactly the same, right? You have all this order and all these rules that we can follow, and everything always works out. Pretty much. It's a little crustier. Oh, did you got it now?
Yeah,
Good.
I got it.
I love when oh yeah. It's a little crustier when the middle term's odd. Completing the square becomes not such a fun process anymore. So in this case here, we have a problem that's not going to factor. So we're going to use complete the square, and we have an odd b term. So a little bit of a fraction coming in. Half of 5 squared is 25 fourths, right? So we got to add 25 fourths to both sides here. So I go ahead and I add 25 fourths to the right side and left side. And what happens now is I get x plus 5 halves squared over here. And over here, technically 5 is also the same as 20 fourths, so that ends up being 45 fourths. So we have a fraction. Take the square root of both sides, because we got the x stuff by itself, sort of. We're going to end up with, in this case, x is equal to, the 5 halves goes on the other side and becomes a negative 5 halves, plus or minus the square root of 45. That's the same as the square root of 9 times the square root of 5. And the square root of 4 on the bottom, if you break them up, square root of top, square root of bottom. Square root of 4 on the bottom is 2. And the square root of 9 times the square root of 5 on the top is going to be 3 root 5. So a lot of times it's the stuff that we already worked on with the radicals that you need to know to get your problem perfectly right at the end. That kind of gets people, because like I was just talking about earlier before we started this video, was that math just builds on itself, and the skills that you learned in one lesson earlier in the year, you're required to use that stuff down the road. I'm going to skip the next one for now, just to kind of keep us moving along. It's the same type of problem with an odd B term, and we'll go into some other situations. So here we have a situation where every term has a constant factor of 2. Okay, so every term we could factor a 2 out, or you could divide everything by 2. So if I divided everything by 2 in my equation, it's going to be an easier equation to deal with. So you might as well do that. You end up with x squared minus 11x plus 30 equals 0. And so do that, and then before you go and start completing the square, just look and see, does this factor? Are there 2 factors of 30 that add up to 11? I'll be gall danged, there are. So this one does factor. X and X. Signs have to be the same because that's a plus. So the signs are both going to be minus minus because I need an negative 11x. And 6 and 5 are going to be the factors of 30 that work. So now when I solve this, my 2 solutions are going to be positive 6 or positive 5. So who votes that that was slick? Let's see, 1, 2, 3, 4, 5, 6. All right, almost everyone except for a few. This next problem's a bit crusty because you get fractions, but that's all right. We can deal with a little crust. Divide both sides by 3. Divide everything by 3, because you can't complete the square until x squared is 1. So that's a little bit of the problem sometimes with complete the square, is if there's a number in front of x squared, I probably am not going to use complete the square because it becomes kind of messy. But if we did, we'd end up with x squared plus 4x plus, now we got to have a special number, equals 1/3 plus that same number. That number in this case is going to be 4. So it's 4 over here, but instead of 4, I'm going to write 12/3 just to make a common denominator. Are you cool with that? Then over here we have x plus 2 squared, and on the right side we have 13/3. Next step, square root both sides. Don't forget the plus or minus. So now we have x equals, the 2 goes over to the other side, becomes a negative, plus or minus root 13 over root 3. Right? You can break them apart. And you may remember from the beginning of the year that you can't have a radical in the denominator. So now we have to rationalize this denominator and get rid of that root 3 in the bottom. So our final answer, all nice and perfect, is negative 2 plus or minus the square root of 39 over 3. Where'd I get the 39 from? I multiplied those together. Where did I get the 3 from? That's why I multiplied by root 3 times root 3 to get the root to go away. And the negative 2, of course, nothing happened to that. All right. The next 2 are review questions from Vertex Form, so I'm just going to let those go, and so for sake of time. And then here's your assignment for today. And if you guys could help me out when I'm checking, if you can put on here like 5.4 and then the page number and all that stuff, that helps for me to check. All right, Adios.